Hello, marhaba, and kalimera. Today I want to talk about cubless Gammon rates, an educational exercise with no practical value whatsoever. And if education scares you, there are some interesting and counterintuitive facts about Gammon rates, and one surprising relation which might be totally new. So stick around, and if you heard any of it before, I would love to hear where and when, right after you jiggle that like button. So let's get going. And first, pretend that computer players are good proxies for humans. There's no other choice. It would take about 200 players a year without sleep to generate the 10.5 million games that Nessinode crunched in less than a day. And for the sake of context, let's pretend further that the new Backgammon site Tabletayment hired me to implement a suitable rating system. Tabletayment is a Middle Eastern or Balkan-friendly site where users play tavla, traditional backgammon with no doubling cube and no backgammons. But gammons count. Now, it's common knowledge that the cubeless gammon rate is about 26%. That is, about 1 in 4 games end in a gammon. But that is for bots or strong players playing other masters. It stands to reason that strong players not only win more, but win more gammons. Which is why I sent my 14 loyal bots to play 100,000 games against the other 13. This is science class, not storytelling 101. Look for example at the games between Zippy and number 9. The more we look, the stranger it gets. Zippy, as expected, wins more games and more gammons. But look at her gammon rate. Almost 40%. 9% more than number 9. Much higher than 26, but she's world class. However, 30% for number 9 is harder to grasp. Who thought weak players can surpass the normal rate by 4%? Is that an anomaly? Not at all. But to show you a complete slide with all gammon rates, we should first discuss ratings. Specifically, how do we measure the skill difference between Zippy and number 9? At least 3 options come to mind. First, we can take wins only. 66.5% is 595 backgammon ELO rating points. Second, we can use total points. Zippy won about 92,000 points versus number 9, 43,000, 68%, or 643 ELO points. Third, Zippy won on average 0.49 points per game, or 929 ELO points. Wins only seems to ignore the gammons, and total points might generate, in extreme cases, invalid ELO ratings, which leaves only per game equity. But here's the thing. To implement a rating system, we will need the win rate anyway. So let's save ourselves some complications and use the win rate as our base ELO. I will return to options 2 and 3 later. That settled, here are the ELO ratings for Zippy and her 13 disciples. And this is a slide of gammon rates as a function of rating difference. I marked Zippy and number 9 in red, minus 595 and 30% for number 9 on the left, 595 and 39 for Zippy on the right. So 33 is not an anomaly. Gammon rates are all over the place and can be anywhere from 26 to 50, even for same skill players. Total madness at first sight. But help is on the way. When we mark Zippy gammons in orange, we can see they are roughly linear. Same for number 14, the weakest player, marked here in yellow, and for the others as well. Which means gammon rate depend on absolute strength, not relative. This insight makes it easy to construct a formula for gammon rates as a function of players' absolute ELO rating. This formula is accurate to within 2 to 3%. Which is great given the high variance between players. So now we can paint the landscape of gammon rates. As expected, the tougher your opponent, the less gammons you get. Here it manifests by horizontal lines getting darker when going left to right. But less expected, the higher rated you are, the less gammons you get against a fixed opponent. At 2,000 players, gammons at 1,200 40.5% of the time, but a 1500 can do 42%. In this diagram it shows as vertical lines getting brighter going top to bottom, instead of darker. It seems very counterintuitive, so here's a story that may help. It's gammon rates we're talking about, not total gammons. Lower rated players win less games and less gammons. But when they do win, it usually involves massive jokers even strong players can't recover from. And one common scenario we all know and love is hitting a checker and closing it out, which results in a lot of gammons. So, while lower rated players win less, many of the wins are of this kind, gammons. Also notice that number 13, a 1050 ELO player, is not making one silly move after another. He plays reasonably, blunders occasionally, and here rolled 2 big joker leading to a relatively easy position to play. So in summary, the massive luck weaker players need to win results in high gammon rates. And total gammons, that is gammon from both sides, also go up when total rating goes down. Tabla is a very strange world indeed. It's good news and it's bad news. It's good to have a formula for gammons, and bad because gammons depend on absolute and not on relative ratings, which violates the central tenet of the ELO system. Let's ignore that for now and establish the basic tablatement rating system, because that involves something we haven't seen before: multi-value inputs. In Tabla, there are 4 possible outcomes: a win by 1 or 2 points and a loss by same, and the system needs to adapt accordingly. The rating difference gets converted to win probability as usual. But now what? The idea, as you hopefully remember, is to balance the updates when the estimated ratings are equal to the true ratings. And balanced mean they should sum to 0 over the long run. It's easy to do so employing the same standard trick used in the vanilla ELO system. First, write the probability of each outcome. Alice gammons happen P times G sub A, her win probability times the gammon rate, which we compute from the formula. Regular wins happen P times 1 minus the gammon rate, and the same for Bob. Now multiply each probability by the number of points Alice gets in each case, and sum the 4 terms to obtain Alice's expected win amount, which after a simple simplification can be written like that. So in the update, Alice gets the difference between the number of points she actually won or lost and her expected value. Let's do one concrete example. Let Alice ELO be 1800 and Bob 1500. Alice wins 58.5% of her games with a gammon rate of 35.6. She wins on average 0.25 points per game. So with a K of 4, Alice gets 3 points for a win, 7 for a gammon, and loses 5 and 9 respectively. I would be happy with those values as a user. That took care of a simple game. But obviously, tablatement users want to play longer matches as well. And it's not hard to do. Without the doubling cube, it is straightforward to compute the probability of winning an endpoint tabla match given the base win probability P and the gammon rates. And while we have the luxury of having a direct computation, it's still interesting to examine the range of B-line ratios. That is, the ratio of winning an endpoint match to winning a one-point match, where the win probability is expressed as the ELO difference between players. Here are the landscapes of the 3, 5, 7 and 9 point matches. We can summarize the landscapes by averaging over the whole terrain and graph the mean value against match length. And voila! The means sits almost perfectly on the square root curve. That is, with just a small correction term, whose value is close to 1. This is actually quite surprising. Tabla with a fixed gammon rate is nowhere near the square root. But with the real funky gammon rates, they adhere to the square root almost to a T. I would class this somewhere between astonishing and a miracle. Anyway, I implemented a demo for the board, and here is a run for 3 players, rated 1800, 1500 and 1400, playing a random mix of single games and 3 to 7 point matches. All well, but notice I started the system with an initial value of 1566 because absolute ELO matters. When we start at 1500, the system does what all ELO systems do: find the best spot given the constraints. Here 1332, 1436 and 1731, which are off by 4 to 5 ELOs. And this is where theory stops and practice steps in. Can we fix it? It's doable. I found some hacks that should work. Is it worth it? Probably not. The hacks complicate the system and add more unwanted variability. And given the relatively small deviation from the true values, it hardly seems worth it. Especially since an actual system with hundreds of users will probably have a mean around 1500 anyway. And if not, the ratings can be adjusted every, say, 6 months to reflect the true mean. So it's safe to say we're done with tableautainment and I can serve my promised surprising fact and sign off. And this happily coincides with my promise to return to options 2 and 3 of measuring skill difference, because this is how I stumbled on it. I was looking at the relation between the wins only equity and the points per game equity, options 1 and 3, and naturally started with the graph, and was surprised to see it was almost linear, and astounded to find a simple relation of y equals 1.5x. There are several ways to phrase the relation, and here's one option: x win rate times x gammon rate minus o win rate times o gammon rate is equal to half the difference in win rates. Put another way, x total gammons minus o total gammons equals half of x win equity. And here's a third: x win rate equals the ratio between half minus o gammon rate and 1 minus the sum of o and x gammon rates. This last one is the most intriguing. If your gammon rate is 35 and mine 25, that implies your win rate is 62.5%. Intriguing, because something so simple should have a simple explanation, but I can't think of any, especially since determining the gammon rates involves such a messy formula. It's like a Leonard Cohen song. It's beautiful and you feel there's meaning behind it, and you know he certainly refers to some concrete events or people in his life, but you have no idea because everything is shrouded with poetry. And I should mention that both formulas can't be completely right, because they fail to extend beyond the 50% gammon rate. They do cover all the human range, so they must be the linear part of some unknown exponential trend. If you have any idea where this relation sprung from, please chime in. That's all, folks. Hope you enjoyed this short side trip, and I'll be back with more ELO later. Shake well, make the best of your rolls, and if your opponents keep complaining about rigged dice, you're sure as hell doing something right.